I want to lay out the procedure for actually solving force problems with numbers. And it kind of ties together everything that we're going to be doing this particular unit. So, first, draw a labeled free body diagram for each object. 2. Use Newton's second law. That's the F equals ma equation for vertical and horizontal forces. If they balance, we can say the sum of the forces equals 0. And if they don't balance, then the forces combine to produce an acceleration. Solve for all unknown forces. Check to see if we answered the problem. That's kind of the procedure in a nutshell. So let's take a look at this problem here. Now, we're going to do a problem where we set up this whole thing. Let's begin with our free body diagram. So we'll have the normal force on big M, the weight of big M, and then there's a tension force. For little m, we have the tension force pulling up and the weight of little m pulling down. Now let's go ahead and set up, let's actually follow this, and this should actually be, I'm going to add one more thing to this for each object. So let's go ahead and do that. So for the big mass in the horizontal direction, I'm going to call that x. I'm going to have tension makes big mass accelerate because there's no balance. In the vertical direction, in the y direction, we have the normal on big M balance minus the weight big M. Those two have a tug of war, and the effect is nothing happens in that direction. Now, we know that this m moves forward and little m moves down since we don't have any friction. So I'm going to define downward as the positive direction. If I do that, then I'm going to have the weight of the little mass having a tug of war with the tension, and the effect is that little mass accelerates. Now let's go ahead and plug in some numbers. Now, not all of these numbers are going to be useful, but we're going to see what we can get. So in the x direction, I have the tension equals 10 kilograms times A. So we can't plug in anything here. A lot of my students will try to plug in 9.8 here because they don't know what to do. No, this is an equation with two unknown variables. We can't do anything with it. Now in this direction, we have mg minus t equals m times A. And so we've got all our horizontal equations. So I'm going to have 5 times 10 minus t equals 5 times A. By the way, let's take a look at the vertical equation off to the side here. It turns out we're going to get the normal force on big M as balancing the weight of big M. So they cancel. And so I happen to find out that the normal acting up on mass M is 50 newtons to balance the weight here. That information is true, but it's actually not useful for this problem. So I'm glad we solved it because sometimes we'll need this, but in this problem we don't. So it looks like we've got the equations that are relevant are t equals 10a and 50 minus t equals 5a. I say let's solve by elimination. So this 10a, I'm going to put it in here to eliminate t. So I'll get 50 minus 10a equals 5a. And so a ends up being 50 over 15, which is 10 divided by 3, or 3.3 meters per second squared. When we go back and solve for the tension, the tension is going to be 10 times A, using this equation here. And so I get that the tension equals 10 times 3.3, which is going to give me about 33 newtons worth of force.